Here we go. The following data represent the muzzle velocity in feet per second of rounds fired from a 155 millimeter gun. For each round, two measurements of the velocity were recorded using two different measuring devices, resulting in the following data. Well, why are these matched pairs? Because all the measurements came from rounds fired from the same gun. Two measurements were using different instruments, and per round, two measurements by two different recorders were taken. Is there a difference in the measurement of the muzzle velocity between device A and device B at the alpha equals 0.01 level of significance? By the way, we're told that it looks like we do have normal distribution of differences, no outliers. So, is there a difference? Regardless, the null hypothesis would always be equals, and in this case, with matched pairs information equal to zero, saying that there is no difference. Asking, is there a difference, is implying a two-tailed test compared against the same number. So, then we are asked for the t statistic. Since this is two-tailed, we take that 0.01, subtract from 1. Sorry. No, we're not comparing to a confidence interval here. So, okay, we already have an alpha, but since this is two-sided, we need to divide by 2. Because we are going to be looking at a table that has just what's in the right tail. We have 6 pairs, so the sample size is 6. One less than that is how many degrees of freedom we have, 5. I will be looking at the intersection of the 5 degrees of freedom row with the 0.005 column. So 5 degrees of freedom right here, and the 0.005 column here is giving me 4.032. Not sure if it let me copy and paste that or not. Let's see if pasting that works. Nope. Okay, 4.032. Let me think for a moment. Oh, they did not want the critical T value. I thought they were asking us for the critical T value already. Okay, so that may be useful later, that we had 4.032. We need to first calculate the T based on our data. And so what I'm going to do is put into list 1. So let's see. Stat. Edit. Clear out. Not deleting these columns, but clearing them out. 791.6. 792.8. 792.2. 794.5, 793.2, and 790.8. Double checking real quick. Okay. And then into list 2, the measurements from device B. Double check those real quick. Okay, it looks like I've got it right. Okay, so we're supposed to be doing the differences where we subtract measurements from device A minus the measurements from device B, because that's the way the author set up the question. If we reverse that everything would have opposite sign. We could get to the same conclusion if we're consistent about that order of subtraction. I'm going to let the calculator do the subtraction for me by going to the top of list 3 and then telling it subtract things in list 1 for device A minus the things in list 2 for device B. And it automatically fills all those in. Then to get my mean and standard deviation, let's see here. We can go to stat again and calc one variable statistics. I'm getting a D bar of 1.15 that is negative. And S, not sigma, 5.14, 344, 27, all of that divided by the square root of the sample size. I'm going to show a little shortcut here. Give me just a moment, though. So this is what I'm going to be entering in. And since square root of 6 is between 2 and 3, this is close to 6. I expect this to be around 2, and so I expect a score for t to be around negative 0.5, negative 0.6. Well, rather than typing that stuff in, I could just do the following. Since the differences were in list 3, then I'm going to get the mean of the sample differences, the D bar, second and stat, coming from math, option 3. Tell it that things were in list 3. Close that parenthesis, and then division around S, second and stat, math again, and it will pick the correct standard deviation. It's going to give us the sample standard deviation. Again, that came from list 3. Close that parenthesis, divide by the square root of the sample size 6, and then close the overall mini fraction that we're dividing by. And I was saying that I expected between negative 0.5 and negative 0.6. If I typed in what I showed you I'd written by hand, then I would get the same. If you do it that way, if you break it down into steps, do not round at every single step. Wait till the end. Now it tells us round to 2 decimal places. I can see that the calculator is giving me, because I put it in all at once, something as close to exact as it can. Now, if that were positive, that would round up to 0.55 because of the 7 after the 4. So this is going to be negative 0.55. Critical value, that's what I pointed out earlier. So let's see here. Let's see the table again. And that was the 4.032. Since, well, let's see here. It might want to negative. Oh, critical values. Okay, this is a two-sided test. They want 2 values here. What would be extreme on the left? What would be extreme on the right? And so I put plus and minus the critical value that I found from the table. 0, 0. Okay, one moment. Okay, I think I know what happened there. For some reason, they want us to round what has already been rounded to 3 places in the table. They're wanting it to 2 places. Okay, we're good. What is our conclusion regarding the null hypothesis? Well, we had negative 0.55 for our t-value compared against negative 4.03 and positive 4.03. That negative 0.55 is in between. It's a little bit left of zero, not as far out as here. Our critical region would have been in the tails. We were testing at the 0.01 level, so 1%. We want a total of 1% in the tails. We were asking, is this extreme or unusual? Is it getting out, since it was negative, is it getting out into this tail? And it's not. So I believe we should be saying that we failed to reject H naughts. Let's see if we get agreement. Do not reject H naught. There is not sufficient evidence at the alpha equals 0.01 level to conclude that there is a difference. We're sticking with believing there is no difference because there is not sufficient evidence that there is a difference. The confidence interval. Okay. Well, we already took half of alpha and got 0.005, and we found that critical value of 4.036 or 4.026. Let me check there. 4.032, sorry. Okay. Let's see here. 100% minus 99% will give us 1%, which equals, as a pure decimal, 0.01. That's the alpha we had. We divided alpha by 2 for this two-sided test to get our critical t-value to compare against, just like we divide alpha by 2 when we're given the confidence level. We find alpha, we need to divide by 2 because the table is only showing us what's in the right tail. So let's see here. Our D bar was stored here in list 3. Subtracting is going to get my lower bound. So I subtract the margin of error, which is calculated by taking your critical t-value of 4.032 times our standard deviation for the differences in the sample. Again, that was in list 3. Notice how I'm closing that stuff after I type list 3. I'm closing that. And then our sample size was 6. Now, since you're not seeing me type in the numbers here, remember I said S over square root of n was going to be between 2 and 3. And we're subtracting that from D bar. So I'm expecting something between -3 and -4 for a lower bound. Oh, I forgot about the multiplication by the t-value. So between -2 and -3, multiplying by something close to 4, between -8 and -12. Subtract -1 minus something between 8 and 12. I'm not surprised to get -9 point something. Switch it to addition. There's the upper bound. So the confidence interval is rounded to 2 places, -9.62. That's 6 after the 1 is rounding that. That's our lower bound. And our upper bound rounding up to 7.32. So one could be 99% confident that the population mean difference lies within the interval found above. 0 does fall within there, which is why we failed to reject H naught in the related two-sided test, where we were dealing with the same alpha over 2. But there are other things in between those two. And by the way, I know 0 falls in between because it goes from negative to positive. But we could be 99% confident about a value for the population mean difference. Anything that's in between there could have 99% confidence. Okay. Box plot. I am going to turn off my algebra stuff here. Turn on my stat plots. Second and y equals. Stat plot 1, turn it to on. If it's not on, you can either do what I just did or press enter and do this. Box plots. Looks like right here. And I'm going to have that information pulled from list 3. Then press zoom and zoom stats. We see a median just a little bit left of 0, but not as far as -1 apparently. 1, 2, 3, 4, 5, 6, 7, 8. These all have a left tail going pretty close to -8. Choice C looks really symmetric to me. Looks like we're going 6.5 units roughly in either direction. This one, about 6 units that way, whereas about 6.5. Those both have the median at about -1.5. Okay. Let's go back to stat and calc and one variable statistics on list 3. Between what we are seeing from the box plot just produced by the stat plot, that minimum of -7.7, it's really tough to tell much difference for how far left any of those are going. But quartile 1 at -6.1, these two are possible. All of them look pretty possible, except possibly with the exception of B. That looks to be right at -6. Median of -0.55. That's going to be right about here. So this one's too far left. So was this one. That one's too far left, and this one looks like the only one. So I've looked at 3 of the 5 things out of the 5-number summary. Quartile 3 at 3.3, that makes sense. And 4.7 for max. Yeah, it looks like choice B. If I bring back the graph, hopefully that looks pretty similar. Let's see what it says to choice B. Part B. We did not reject. And 0 is within the box plot, so yes. Now, this may be getting kind of long, but I'm going to continue this within the same video. You can't see it. This looks a lot like the same question, but now it has next to the question ID a -T, which means we're supposed to be doing more on technology, less to nothing at all with a table. In fact, let's see here. Here I have the option of clicking. I went to a separate window, but I had the option of clicking to see the critical T values. And now that is missing. So I'm going to enter the new data. Repeat a lot of this and talk about where the differences are showing up. All right. Clear, 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 clear. 793.8, 790.7, 794.7, 794.5, 791.2, and 791.4. Okay, going over here. 799.2, 787.8, 796.1, 793.3, 795.5, and 791.2. As previously, going to the top. Well, let's answer this part first. Should be the same answer. Each round, two measurements A and B from device A and B were taken on the same round. And we are going in the order of device A minus device B. So all this stuff, if we're just asking, is there a difference? We're still talking about a two-sided test in this version of the question, even though now we're supposed to rely more on technology. Okay. So our t-value, get my list 3, and that comes from subtracting what's in list 1 from device A minus what's in list 2 from device B. And it's filled everything in to get my t-score. The new mean of list 3 divided by parentheses around the standard deviation in list 3 divided by the sample size square root of n would be square root of 6. And if this was all new data, then I should have something different from that negative 0.54 something. And I do. So the two places, that's going to be negative 0.86. Okay, one moment. Well, I am not liking that. It's off by a single hundredth. Okay, let's see what happens here. I can get that standard deviation from list 3 to show back up again without having to do the stat in one variable calc. If I divide that by the square root of 6, which was the sample size, I'm not doing any rounding. And then I'm going to divide that by the D bar. That was, again, I could go back to stat one variable calc. Or I could do this to tell me what do we get from list 3 for the mean. So I would divide that answer by this, and I'm coming up with the same thing. So I wonder if I misentered something. I did. That was 795.3, which is going to change what we have here. Unlike, say, using Excel, I have to retell it to do all of that subtraction just to get it to fix that 1. And now that it's given a difference of negative 4.1 there in that row, if I go back up here, now that it's repopulated what's in list 3, that would round to negative 0.85. Okay, so just one typo. I did not intend to do that, but this is worth seeing. And my lab has no way of knowing when you're working on the homework. A professor such as myself, when seeing things on paper, we don't know if you entered something in wrong. So there are pros and cons to using technology. Okay, what is the p-value? Well, this is a two-sided test. We don't have a table to refer to. So two-sided test, so I have to double second in distribution, go to TCDF, option 6. Since that was a negative value for t, I would start infinitely to the left of that with a negative 10 to the 99, going up to that finite upper bound of negative 0.85, negative 0.85. Degrees of freedom was 5. And if this were on paper for my students, I would have you round that to 4 places. After writing down what you had entered in the calculator, I would round that to 0.4341. Here they're asking for 3, so that's going to round down to 0.434 due to the 1 after that second 4. And since alpha was 0.01, this probability is a lot larger, so I do not reject. There's not evidence at that significance level that there's a difference. We stick with believing that there is 0 difference. We do not have sufficient evidence for there being a difference. And then the confidence interval. Here again, we do not have the table to refer to. So I would have to take 100 minus 99, divide that by 2, turn that into a percent. Dividing by 100% is the same as dividing by 1. So I'm just changing how it's expressed. 0.5% is equal to 0.005. And again, we can't look up on the table. So here's what I have to do. Second and vars will get us into the distributions. Same place where we found TCDF, we find inverse T. I want an area of 0.005 that I just calculated when there are 5 degrees of freedom. We can, since our confidence interval formula has a plus minus in it, we can take just the positive version of that, the absolute value. So my lower bound would be from the mean of list 3 minus the, here, let's do this. Let's change the sign of that. Okay, hold on. Okay, so absolute value, we're doing this to change the sign. And so mean of list 3, darn it, mean of list 3 minus my margin of error, which is that critical value, times standard deviation from list 3, divided by the square root of the sample size. And switching that to addition to get our upper bound. 2 places, negative 6.33 and 4.13. Each of them has a 4 in the thousandths place or 3 places after, so both of those are rounding down. Negative 6.33 and 4.13. As with the previous version of the question, when we were not using the technology as much, we can be 99% confident that whatever the mean difference is, whether it's the 0 that we did not reject or something else in between these two values, we would be 99% confident that it's in between those two values. And I will get my one variable statistics for list 3 again. Negative 1.1, nope, negative 5.4 is the minimum, and that leaves C out. All the rest seem pretty close, somewhere between negative 5 and negative 6. Quartile 1 at negative 4.1, that's kind of close. Kind of close, kind of close. But where they're showing the median seems to be significantly different. Negative 0.6. This is left of 0. This is a lot closer to negative 2. It's past negative 1. And same with this. Looks like it's choice A. You could continue by looking at quartile 3 and the max as well. But looks like that's good. So because 0 is contained in the box plot, I'm sticking with saying that we should have failed to reject H naught.